Very good evening, students. The last class and the previous class we have seen ray optics first part. We have seen reflection, refraction, real and apparent depth. Also we have seen in a double convex lens SRS, spherical refracting surface, and how the refraction is taking place in the spherical refracting surface, lens maker's formula, and how the deviation of light through the prism, total internal reflections, and so on. But today we are going to see optical instruments. In that optical instruments, we are going to learn about number 1, simple microscope. Going to learn about simple microscope, that is nothing but magnifying glass. Number 2, compound microscope. And number 3, telescope. This telescope has got 2 parts. Number 1, reflecting type telescope. Reflecting type telescope. And number 2 is refracting type telescope. So, come let us learn simple microscope. Now, first simple microscope. Before learning simple microscope, I wanted you to know about the linear magnification and the angular magnification. First, we know about linear magnification, that is only the size magnified. Linear magnification of image. The linear magnification of image M is called as M is defined as the ratio of size of image by size of object. So that is nothing but H dash by H. That is linear magnification. But now what we are going to see is angular magnification, that is otherwise called as magnifying power, which is denoted by MP. This MP is defined as the ratio of angle subtended by image, angle subtended by image, angle subtended by the image by angle subtended by the object, angle subtended by the image with respect to I, angle subtended by the image by the object with respect to I. Image by object, that is only the magnification power. Size of the image by size of the object is linear magnification, that size. But then angular magnification is angle subtended by the image with respect to I by angle subtended by the object with respect to I. If we are going to deal about LDDV, then the image should be obtained as LDDV, or if it is at infinity, it will be at infinity. So, simple way you can write simply as beta by alpha. For small angles, you can write this MP as tan beta by tan alpha. So, actually beta by alpha, but for small angles, you can also write it as tan beta by tan alpha. So, this is angular magnifying power, or this is what we are going to learn in the up next topic. So, let us learn simple microscope. Simple microscope. Simple microscope. So, what is simple microscope? It's actually, the simple microscope is nothing but a magnifying glass. Who will be using it? You must have seen that the watch repairers will be using that simple microscope. Have you seen that? Or otherwise, if you want to magnify the very, very small image, very, very small letters, you will be using it. And biology students would have been definitely known that you would have used in your biology lab simple microscope, or physics lab for Vernier division finding out simple microscope you would have used. So, simple microscope, I am not talking about compound microscope, simple microscope magnifying glass. So, this simple microscope consists of only one lens, that is convex lens. what does it use? Use convex lens to construct. Convex lens to construct. So, I am going to use convex lens to construct this simple microscope. Okay. So, let us see how that the principle is going to be working. So, convex lens undergo refraction. So, where is the object placed? The object is placed between optic center and focal point, between optic center and first focal point, and the first focal point of the lens. So, now where is the image obtained? Image is obtained on the same side, and it should be virtual, erect, and enlarged image is obtained. Virtual, erect and enlarged image. So, let us see the diagram. So, I am going to draw the diagram. So, now here this is convex lens. So, simple diagram let me draw and show you how to draw the diagram, and then you can see the textbook diagram in comparison. So, this is called optic center of the lens. Now, this is called first focal point. I am going to place within the focal point. So, this is a object. AB is the object. The ray passing parallel to the principal axis passes through the second focal point over here. The ray which is passing through the optic center without any deviation, it just goes. So, therefore, produce the rays of light at the back and then check where you are getting the image. So, you get an image over here. So, therefore, you can say you are going to see view from here. So, we are going to view from here. You can see here, we are going to view from here. Got it? So, now angle made by the object. So, this is image. So, let me call it as A dash, B dash is the image and AB is the object. What is angle made by the image? So, that is beta. So, since angle made by the image is beta, let me write here beta. Angle made by the object, that is alpha, but object also you will have to bring it to the image because you are adjusting to get it at LDDV. So, the image distance, that is V is equal to capital D, which is nothing but 25 centimeter. So, you are adjusting the lens. So, with respect to the object in order to get the image at LDDV, so we got it as LDDV over here. So, now the light comes only from the object. So, this is a light coming from the object. But you have to measure the distance. Measure the distance only from where? Measure the distance from the optic center. You measure the distance from optic center of lens. When you measure the distance from the optic center of the lens, of course, against the direction of the light is negative. You come on, tell me which is negative here. Is the object distance negative? Yes. How do you say? Because you are measuring the distance against the direction of the light. So, light is coming like that, but you are measuring the distance against. So, therefore, it is negative. So, therefore, I am writing u is equal to minus u. Tell me what is V here, V distance. So, that is also CA dash. CA dash is V distance. U is minus u. So, that is nothing but CA, and V is nothing but minus V, which is equal to CA dash. But we are adjusting to get it at normal vision 25 centimeter. So, therefore, V is nothing but capital D, which is called as 25 centimeter at LDDV. Okay, angle made by the image is beta, angle made by the object is alpha, but both are at LDDV. So, apparently, I am going to bring this without changing the size of the height of the object. So, apparently, you bring it here. So, after apparently bringing it here, then you can say this angle made by the object is beta over here. You got it? So, now I know the object height, that is AB. It is equivalent to that of A dash P. So, therefore, I can write A dash P is equal to AB over here. That is nothing but H. Okay. So, therefore, A dash B dash is equal to what? H dash. You got it? So, now we know beta, and also, so this is alpha. So, this is alpha because the object distance is what? Object angle is what? Alpha. What about image angle? Beta. So image angle is nothing but A dash B dash C, that is the image angle. See here, this is A dash B dash C, that is image angle. So I know beta, I know alpha, so I wanted to find out tan beta by tan alpha. Slightly let me lift it up and then I will show you here from this triangle CA dash B dash, this is beta. Are you getting? Yes, CA dash B dash is equal to beta. Or you can also write it as this is AB, right? So that is also beta. So I can write tan beta is equal to either this is A dash B dash divided by A dash C, I can write tan beta. Or I can also write AB by AC. So what is ACU? So I can also write it like that. Is that correct? Yes, it is correct. Now I am going to take the triangle A dash PC. This is A dash PC. In this triangle A dash PC, this is alpha. So from this, what is tan alpha? So tan alpha is equal to A dash P. So A dash P is equivalent to AB. So A dash P is equal to AB. So therefore I can write here tan alpha is equal to A dash P divided by A dash C, or you can write it as AB divided by A dash C. So therefore A dash C is nothing but minus D, or you can write it as D itself. So that later on after applying sign convention you can write the same thing. So this is equation number 2, tan beta is equation number 1. Okay, so I have found out this 2 equation. So tan alpha I wrote it here, so therefore I don't want it, I am erasing it. So I know tan beta, I know tan alpha. So therefore magnification power I am going to find out. So how will you find out the magnification power? Let us go to the next page. So magnification power is defined as beta by alpha. Just now we saw. Same thing we are going to have is equal to beta by alpha. For small angles I can write it as what? Tan beta by tan alpha. That is all, children, very easy. What is tan beta? You wrote. Just now we wrote no tan beta. AB by AC. What is tan alpha? AB by A dash C. So therefore I can write AB by AC divided by AB by A dash C. So what happened to AB? AB get cancelled. A dash C by AC. So therefore magnification power is equal to A dash C by AC. Children, come here to this page and then you see the diagram. What is AC? Sign convention, what does it say? Yes, U, minus U. What about C A dash? That is minus V. Sign convention says. So therefore I am writing the same thing here. So here that is equal to A dash C is nothing but minus V. So I am writing minus V divided by minus U. But what is V? V is nothing but least distance of distinct vision, therefore D by U. So finally I got the result MP is equal to D by U. So therefore I am writing this is equation number 3. But I wanted to write in terms of focal length. So we know that by lens formula. So by lens formula we know that 1 by F is equal to 1 by V minus 1 by U. Is that correct? Yes. So apply sign convention. So therefore 1 by F is equal to, I am applying sign convention, minus 1 by V, because V is negative, plus 1 by U. Now after applying sign convention, multiply by D. What is D? 25 centimeter, least distance of distinct vision. So therefore D by F is equal to minus D by D. Why am I writing D by D? Because V is equal to D plus D by U. Why do I want to multiply? Because I wanted to get D by U. So therefore D by F is equal to minus 1 plus D by U. So therefore what is D by U? So D by U is equal to 1 plus D by F. So we got 1 plus D by F. So this is equation number 4. So therefore from equation 3 and 4, can you see here 3? Yeah, 3 is D by U, and then here this one D by U is 1 plus D by F, 4. So therefore from 3 and 4, tell me children, MP is equal to what? D by U, which should be written as 1 plus D by F, that is all. So we finally found out the magnification power that is 1 plus d by f. This is for what? LDDV, image at LDDV. This is for the image at LDDV. So we found out, now we are going to find out how is that image at infinity. So now before going, let us see this diagram. What is this diagram says? Diagram 1. So diagram A represent image formed at what? Image formed at LDDV. So image is formed at LDDV, and then this magnification power we found out as 1 plus d by f. Now we are going to see image formed at, second case, image formed at infinity. See here, image is forming at infinity and producing it back. Where can you place it? Within F, you place it, adjust. But instead of getting at 25 centimeter, image is at infinity. So, the ray of light from the object passing parallel to the principal axis passes through focus. Another ray of light passing through the center of curvature without any deviation just goes. So, therefore, produce it back, then it will meet at infinity. Right? If it is at LDDV, then you get it like this. You got it. So therefore, I am going to find out, in this case let us find out what is theta I. So theta object, this is theta image. So theta object, so from this object angle made by the object. So magnification power is equal to angle made by object, angle made by image, I am sorry, angle made by image divided by angle made by object, with respect to I, So therefore, beta by alpha, for small angle tan beta by tan alpha. So therefore, this is nothing but beta here. This is beta, this is object is alpha. So beta is nothing but h by f, alpha is nothing but h by d. H get cancelled, so you get d by f. So magnification power for image formed at infinity is just d by f. So what is the difference between the previous one and this one, children? Nothing different. It is 1 plus d by f. This is d by f. Which is higher magnification? 1 plus d by f is one addition. So therefore it has higher magnification than this. So hope you understand what is d, 25 centimeter. So if I give you the focal length, for example, if focal length of convex lens, given convex lens is equal to, for example, 10 centimeter. Find magnification power, find its magnification power for, that means the magnification power maximum and minimum, both are asked. So therefore, maximum magnification power, you write it as MP is equal to 1 plus d by f. So that is equal to 1 plus 25 by 10. So that is equal to 2.5. That's nothing but 3.5. Minimum magnification power is equal to just d by f. That is equal to 25 divided by 10. That is equal to 2.5. So hope you understand this concept, children. Let us go to the next topic, that is compound microscope. It's very easy. So let us, if you know the simple microscope, you can definitely understand the compound microscope. Keep it in mind what's the principle on which the simple microscope works. That is very easy, children. Where do you place an object? You place an object within the focal point. Can you see here? So you place an object within the focal point. So within the focal point is nothing but between C and F, between the optic center and the focal point. So when you place it, you get the image at the same side. So now what kind of image is obtained here? What is the nature of the image obtained? The nature of the obtained is nothing but virtual, erect and enlarged image. Virtual, erect and enlarged image is obtained. So can we see here? So can we see like the next one, that is compound microscope, what kind of image is going to obtain? So can we go to the next one? So yeah. So compound microscope. How many lenses used? Compound microscope is nothing but compounded in order to get the magnification. So compounded microscope. So therefore double lenses we are going to use, compound microscope. So now uses two lenses, objective lens of shorter focal length, small focal length, objective lens of shorter focal length, that is objective lens. Next, eyepiece lens of slightly larger focal length, relatively. So, I should say relatively larger focal length, relatively. Why only relatively, you will come to know. Larger focal length, but both should be smaller, that we will see. How, where am I going to place an object? The object is placed beyond f. So, objective lens, object is placed in front of objective lens, just beyond f, to get, that is f1 is nothing but first focal point, I mean, to get real inverted enlarged image, This image is going to act like this image obtained is acting like an object acts as an object. Image due to objective lens, image formed is acting as an object for eye lens. It is acting as an object for eye lens, but final image is going to be an inverted image or erect image. The final image is going to be an erect image with respect to the eye lens. So, let us see eye lens. For eye lens, image is obtained at the same side of it, So, the final image which is obtained due to the eye lens is actually virtual erect with respect to the eye lens. So, let us draw the diagram. So, how to draw the diagram? So, this is how you need to draw the diagram, but I am going to teach you how to draw the diagram and then we will go there. So, first of all, you draw. This is a little tricky to draw. So, when I am drawing, you draw, so that will be easy for you to understand. By looking at this diagram, you will be thinking that it is very easy. Oh, wow, it is very easy, you can just draw. But actually, so it requires some, kind of tricks. So, first you draw the convex lens, that is objective lens. Draw only smaller lens. So, now smaller focal length, I mean. So, now this is actually the principal axis. Draw principal axis. After drawing principal axis, the ray is passing parallel to the principal axis. I told you the object should be just beyond f, so that you will have to get a real image. So, just beyond f, the ray passing parallel to the principal axis passes through f. So, now this is image obtained is acting as an object for, this image obtained is acting as an object for the eye lens. See here, the image obtained is acting as an object for the eye lens. So, now the ray is entering into the eye lens. I am adjusting the eye lens. This is how we need to draw. First, initially don't draw both the lens. First draw one lens. See how I have drawn, see here. So, I have drawn like this, one lens, and then I am getting the image. Now, what happens? Another lens I am drawing. So, therefore, the ray which is passing through this is A dash B dash. So, this is AB. So, this is objective distance for the objective lens. So, therefore, U naught. Which is the image distance? This is the image distance for the objective lens, V naught. Light always comes from the object, therefore, I am drawing that like that. So, now you understand, step by step you learn. Be careful, be here. It is very easy to learn. Just 5 minutes enough for you to focus this and then you get it done. Okay? Derivation part is not a task at all because you have already learned simple microscope, same thing is going to reflect. So, diagram only just matters a lot. You have to be very, very careful while you are drawing the diagram. So, see to that, you draw first lens and then get the image. That image is acting as an object for the eye lens. So, therefore, I am putting an eye lens here. So, the image is acting as an object. So therefore it gets refracted and then produce it back in order to get the image where at LDDV. So I am producing it back in order to get the image at LDDV. So I got the image at LDDV. So I am getting the image at LDDV. Therefore, here another ray of light, I have to take it here. So after taking it, I am going to call this as, this is beta. I can take this as beta over here. This is an I. Because this is where is image formed? Here is an image formed. A double dash, B double dash. Now this is called as object distance for the eye lens, therefore you call it as UE. Be careful. Therefore, this is called as tube length, that is nothing but VO plus UE. Actually, how do you define tube length, Tube length, how can you define? Tube length is defined as, you see the NCERT textbook tube length is defined, though you write this distance. Tube length is the distance between the second focal point. Which focal point? Second focal point of the objective lens. Objective lens second focal point, where it will be possibly? It will be here. So, the distance between the objective lens second focal point and the eyepiece lens first focal point. That is how you need to define the tube length. So, how do you define tube length? Come on. It is the distance of separation between the second focal point of the objective lens and which focal point? First focal point of the eye lens. So, tube length. So, tube length is equal to L is equal to VO plus V0 plus UE, mod of UE. That is tube length here for this, because we adjust to get the image like that. Now, when you see only this eyepiece, so when you see only this eyepiece, it is similar to that of the simple microscope you have learnt. Same side you are getting the image. So therefore, what am I doing? This eyepiece here I have taken, right. So that is similar to the simple microscope. So same diagram I am going to draw. Same magnification I am going to take. So let us take the same magnification. Yeah. So what is the magnification of the magnification power, which is equal to magnification of the objective into magnification of the eyepiece. So for simplicity, let me just erase this so that you will have a clarity. Yeah. So it will be like same way. If you want me to erase this one also, let me erase. Okay, fine. So magnification power is equal to MO into ME. I have already told you eyepiece is similar to that of what? Simple microscope. So therefore, let me write magnification power is equal to magnification of the objective into magnification of the eyepiece. Magnification of the objective is linear magnification, that is equal to minus V0 by U0. How minus? Because light comes from left to right, but then this is V0 is positive, but UO is negative. So let me write V0 is equal to plus V0 and U0 is equal to minus U0. What is U0? Objective lens. Similarly, UE is equal to minus UE and VE is equal to minus VE. So these are the sign convention. I am going to get it for LDDV, so therefore I am letting this as least distance of distinct division. Now come on into magnification of the eyepiece is 1 plus D by FE. Where have we learned this? From simple microscope. You can simply write from simple microscope, we know that. We already learnt and then we already derived. So you may be wondering, in the examination, do we need to derive simple microscope and show? Not at all need it. You can simply say that we know that from simple microscope, 1 plus d by Fe. Therefore, magnification power for LDDV, image at LDDV, can be simply written as minus V naught by U naught into 1 plus d by Fe. That is all. Now, special case, if image is at infinity, not at LDDV, but it is infinity. How do we modify this magnification power? So, we will see this diagram. So, this is the same diagram I have drawn here. Instead, if it is going to be at infinity, you don't need to draw the diagram. You can simply say that. So, for the image at infinity, so what do you say here? For image at infinity, V naught is approximately equal to, so this V naught is there, no, so image distance. So, that will be approximately equal to L, because the image will be obtaining very closer to this point. So, very closer to the point, therefore, UE may be very small, it can neglect it. So, hence I am saying V naught is approximately equal to L. Okay. So, therefore, and U naught is approximately equal to F naught, focal length, because you can get it only if the object is placed very closer to the focal point. So, therefore, it is focal length. What's focal length? First focal length here. So, I can write here U naught is approximate. Therefore, MP can be written as minus L by F naught into 1 plus d by Fe. But from simple microscope, 1 plus d by Fe is not 1 plus d by Fe, it is only what? Just d by Fe. So, therefore, you can simply write it is not 1 plus d by Fe, rather you can simply write it as minus L by F naught into d by Fe for image at what? Infinity. Now, you can understand that the magnification power is inversely proportional to that of F4 and Fe. So, therefore, you can say both focal lengths should be smaller in order to have greater magnification. Both the lens should have smaller focal length, to achieve greater magnification, You understand? So, in order to obtain the greater magnification, you require the smaller focal length. So, now let us see this. Clearly, to achieve a larger magnification of a small object, hence the name microscope. Clearly, to achieve a larger magnification of a small object, the objective and eyepiece should have small focal length. One more question will be asked. So, you will be given set of focal lengths. One is 10 centimeter, another is some 100 centimeter, another is going to be 12 centimeter. So, you will be asked to take or choose the focal length, or you will be asked to choose the convex lens in order to construct the compound microscope. So, which one you will have to choose? You have to choose 10 centimeter for objective lens and 12 centimeter for what lens? Eyepiece lens. So, you should not say that by looking at this diagram, you should not say that, oh, it is really big, therefore, I have to choose only 100 centimeter. No, because we have already learned that magnification power is inversely proportional to focal length of the objective lens as well as eye lens. So, therefore, both the focal length should be of smaller range order in order to have higher magnification. So, hence it has been given here, in order to achieve a greater magnification, both should have smaller focal length. In practice, you look at this line, it is very difficult to make the focal length much smaller than 1 centimeter, Also, the large lenses are required to make L large. If you are going to use a large focal length, the L will be typically large. It will be very huge. It will occupy the space distance between the two lenses. So, therefore, for example, with an objective lens of focal length 1 centimeter, eyepiece length of focal length 2 centimeter, and a tube length of 20 centimeter, the magnification is 250. You get it like that. But the grinding of focal length is very, very less, very, very difficult. Why grinding a focal length to smaller focal length? Very difficult, you know. So if you are going to take a smaller focal length grinding, you will have to encounter this aberration called as spherical aberration. So the rays of light will not be able to meet. See, marginal rays of light will be able to meet this much distance, whereas the paraxial rays will be able to meet only this much distance. This is called as aberration. What is aberration? Defect in the lens. What is happening here? The light is not focused at single point. You can see intensity would have been reduced. Therefore, it is difficult to grind focal length of smaller focal length. Hope you understand, children. So, you must understand that both should have smaller focal length, but though both should have smaller focal length, you can't, beyond certain extent, you cannot reduce the focal length. You hope you understand. So, now we will go back to the next, that is telescope. So, will we go back to the, telescope. So, now telescope, we will take telescope. What telescope we are going to take? Number one, refracting type telescope, that is all astronomical telescope only I am going to take it. Refracting type astronomical telescope, not terrestrial one, we have it in syllabus only, astronomical telescope. So, refracting type. It uses two lenses. The objective lens should have very large focal length. So, let me write down this lens used. Convex lens, and objective should have very large focal length. It is not like compound microscope. It should have very large focal length. Eyepiece should have very small focal length. It is not only very large focal length, should have large aperture. It also should have large aperture. What is the meaning of aperture? Diameter of the lens should be very large. Why? In order to have large light gathering power. You may be wondering why not you have such kind of characteristic for a compound microscope you are choosing, because this telescope, celestial object, is very far away. Where is that celestial object? Is it at the door, back door? No, it is very far off distance. So therefore, the light which is coming from far off distance, by the time it is reaching the earth, by the time it is falling on the telescope, the intensity would have been reduced. But I do not want that intensity get reduced. Somewhat I have to gather more light. So therefore, large aperture, large light gathering power. You got it. Where is the object placed? The object is at infinity. Where is image obtained? The image obtained at F. For objective lens. Okay. At F for objective lens. And where is the image obtained for the eye lens? Therefore, for an eye lens, the image is acting as, an object. You have to adjust. Acting as an object. And finally, we obtain the image on the same side. You can see here the image is obtained on the same side. Yeah. So finally we obtain the image on the same side of eyepiece lens. Or eye lens. So let me draw the diagram same way. So I will teach you how to draw the diagram. This is a objective lens. Do not draw both the lenses together. Now the ray of light is coming from the infinity. So therefore I am putting a dotted line, and it is meeting at F. This is acting as an object for the eye lens. So eye lens is going to be very small. So now it get refracted and here is an your eye. So therefore the final image is formed at infinity. So you can draw the same thing. So and this is beta. So this is alpha, and this is called as tube length, that is equal to FO plus FE. Object is at infinity, so therefore the image is at F. You call it as A dash B dash. So it is at F. Adjusting the eye lens so that the object should be just closer to focal length of the eyepiece. And finally, it is meeting only at infinity. Basically speaking, the telescope does not magnify the original object. Only the points this object it is magnified. But of course, it resolves the object. Resolves. So you can write telescope just resolves. Just resolves, but not magnifies the object. But not magnify the object. Magnify the original size of the object. You know what is the original size of the moon? What is the original size of the Venus? It is very high, very huge, kilometer. Is it magnifying like that? Whenever you are looking at the telescope in Birla Planetarium or whatsoever. So, it doesn't magnify the object. It is just the point it is magnifying. Whereas, in fact, it resolves. Magnify the telescope just resolves but not magnify the object, original object. So now I am going to find out the magnification power, that is equal to beta by alpha. Now it's very easy, you can find out from the triangle what is beta and what is alpha. So you find out what is beta, A dash B dash divided by A dash C2. So that is equal to tan beta by tan alpha. So I wanted to find out, therefore magnification power is equal to tan beta is nothing but A dash B dash divided by A dash C2 divided by A dash B dash divided by, what is this? This is A dash B dash divided by A dash C1. That is what I am writing. A dash B dash get cancelled. So therefore magnification power will be equal to A dash C1 divided by A dash C2. What is A dash C1 here? FO. What is A dash C2 here? That is FE. So therefore you can simply write minus FO by FE. So therefore magnification power can be simply written as minus FO by FE. Minus is not at all a matter for us because it is a negative sign, shows that inverted image with respect to the object, inverted image. So therefore doesn't matter, tube length FO plus FE. But I have already specified that there is an aberration in the lens. I have already told you, due to the aberration in the lens, the rays will not be meeting at single point. So therefore, in order to get a highly resoluted image, so with high clarification, high intensity of the image. So what are we supposed to go? We'll have to go for the reflecting type telescope, one which uses mirror, because the lens only we have a problem of spherical aberration or chromatic aberration. Chrome means color. Different colors of light meet at different points because of the difference in the curvature. Because the lens when you take thick at the middle, thin at the edges, these rays will be able to reach longer distance, but these rays will be able to reach only lesser distance because thickness. Therefore, the intensity would have been reduced. So in order to overcome all this, we are going to see a reflecting type telescope. What type? Reflecting type telescope. So what is the other name of reflecting type telescope? Cassegrain telescope. Cassegrains, named after the scientist. Telescope. So now though the diagram is given over here, you have to check into the diagram. I am going to draw that Cassegrain telescope. It uses parabolic mirror. So first this is a mounting stand. You can also draw when I am drawing, it will be easy. So I am teaching how to draw. Abruptly if you copy, you may not be able to understand, that is why. So now I am using, this is a mounting stand, I am using a concave mirror. You may be wondering where is the concave mirror? Here, you see here. So this is the concave mirror. Now could you believe? Yes. There is an aperture. What is this? This is a mounting stand. So this is mounting stand. So concave mirror is mounted on it. Now I am going to draw the ray of light. See here, ray of light. Ray of light from infinity falls on the concave mirror, undergo reflection. Once after reflection, this is concave, I said, concave mirror. What mirror? Parabolic mirror you take, not spherical one, parabolic mirror. So now the ray after passing through the concave mirror gets reflected. So the reflected rays of light is meeting at F0. At infinity, so object is at infinity, image is at F0. In the path of the reflected beam of light rays, I am going to place a convex mirror. What mirror? Convex mirror. See here. So convex mirror. So I am placing a convex mirror. After placing a convex mirror, we know very well that the convex mirror undergo reflection. So therefore, that means it undergo reflection diverges the rays of light. See, look at the way it is diverging the rays of light. See here. So diverged rays of light, the diverged rays of light is allowed to fall through the eyepiece. You can see here diverged rays of light is allowed to fall through the eyepiece. That's all. Check here. Yeah, it is allowing to fall through the eyepiece, right? Same way you have to draw. I showed you, I taught you how to draw. Same way you can draw. So in this magnification power, what is the formula? Same FO by FE. What are the advantages of it? These advantages, very, very important advantages of reflecting type telescope. Reflecting type telescope. So that is number one, no spherical aberration. No spherical aberration. Number two, no chromatic aberration. Chromatic aberration. Okay. Number three, what is that? High clarity of image. High clarity of image. That is nothing but high intensity of image. Less mechanical support. Less mechanical support. Less mechanical support. You can even say that high resolution. All that are important advantage. So hence we go for the same thing. So far we have learnt all this optical instrument, that is all. So now quickly let us see one question based on that. So I will give you the hint which you can do by yourself. So now at least one part of the question we will see. A compound microscope consists of objective lens of focal length 2 centimeter, an eyepiece of focal length 6.25 centimeter. So the same compound microscope we can take it for a consideration. So here compound microscope, same thing, but consists of objective lens. So roughly let me draw. This is objective lens, this is eyepiece lens. So objective lens of focal length FO is equal to 2 centimeter and eyepiece lens of focal length 6.25 centimeter. Separated by distance L is equal to 15 centimeter. Already we learnt what is L. So I think here only we have learnt. Yeah. So VO plus UE, V0 plus UE. The same thing I am going to take it here. So L is equal to 15 centimeter. That is equal to V0 plus UE. And how far from the objective should an object be placed? So U0 is asked. Whereas the final image is at the least distance of distinct vision. So therefore V is given as, so final image is at least distance of distinct vision. The final image is obtained, no? So that will be at LDDV. Like that it is given. So LDDV is nothing but minus 25 centimeter. All these are given. So U0 only is asked. So only one parameter we are going to find out. First of all, use 1 by F0 is equal to 1 by V0 minus 1 by U0. Use lens formula, very simple. What is F0? 2 centimeter. Okay, V0 do not know, U0 do not know. So Leave it like that. This is for objective lens. Similarly, eyepiece lens you go. Eyepiece. Trial and error. So now this is 1 by Fe is equal to 1 by VE minus 1 by UE. Yes, Fe you know? Yes. VE you know? Yes. Therefore, UE you can find out. So 1 by 6.25 centimeter, 625 by 100. 1 by minus 25 centimeter. So minus 1 by UE. So therefore, 100 by 625 plus 1 by 25 is equal to minus 1 by UE. That is all. Take LCM and find out. 625, 100 plus 25. So that is equal to minus 1 by UE. 125 by 6. So therefore, what do you get here? So UE is equal to, so this is 125 by 6. So that is equal to 5. So UE will be equal to 5. So 1 by 5, that is equal to minus 1 by UE. So therefore, I found out UE is equal to minus 5 centimeter. So hope you understand this. I found out UE. So the next, I am going to take this V naught plus, very easy children, that's all, that is equal to L. So V naught plus mod of UE this is. Because tube length cannot be negative, so therefore always take mod. So V naught plus mod of 5 centimeter, that is equal to L. So therefore V naught is equal to 15 minus 5. So I can get 10 centimeter. That's all. I know V naught, I know UE, so therefore I have to find U naught. Now substitute in this, you get the answer. So 1 by 2 is equal to 1 by 10 minus 1 by U naught. So therefore I can write 1 by 2 minus 1 by 10 is equal to minus 1 by U naught. So 10 is the LCM over here, 5 minus 1, so that is equal to minus 1 by U naught. So therefore 4 by 10 is equal to minus 1 by U naught. Hope you understand children, I am just keeping on doing it. Are you concentrating? Yes, you have to. So now this is U naught is equal to minus 10 by 4, that is equal to minus 2.5 centimeter. So hope you understand children. This is how we need to do it. So it is a 3-mark question. Same way here. A person with a normal near point using a compound microscope with objective of focal length 8 millimeter. So objective of focal length 8 millimeter. Eyepiece of focal length 8 millimeter. Eyepiece of focal length 2.5 centimeter, convert into millimeter, 25 millimeter. Can bring an object placed at object distance U naught is equal to minus 9 millimeter. What is the separation between the two lenses? Only L is asked and magnification power is asked. So can we do that? What is magnification power for LDV? Minus L by F naught into 1 plus D by Fe. Or for image at LDV minus V naught by U naught into 1 plus D by Fe. What is D? Minus 25 centimeter. Is D there? Fe there? Yes. U naught is there? Yes. But V naught is not there. How do we do? So let us take 1 by F naught is equal to 1 by V naught minus 1 by U naught. 1 by 8 is equal to 1 by V naught minus 1 by minus 9 millimeter. So plus 9 millimeter. Therefore 1 by V naught is equal to 1 by 8 minus 1 by 9. So therefore you get, so that is 72. So here 9 minus 1. So that is equal to 9 minus 8. So that is equal to V naught is equal to plus 72 centimeter. I found out V naught, substitute magnification power and get it. So therefore L is equal to V naught plus mod of UE. We have to find out UE, right? So therefore I am going to write here magnification power is equal to minus 72 divided by U naught is 9. So 9 into minus this is V naught by U naught. This minus sign I am taking this as mod. So therefore let me not put it here. So this is mod value, so let me not put it here. So magnification power is equal to 72 divided by 9 into 1 plus mod of D by 25 divided by Fe, that is 25. So 25 get cancelled. So that is equal to 72 by 9 into 2. So therefore magnification power approximately equal to 8. 8 into 2, 16. So magnification power is 16 we found out. So hope you understand magnifying power of the microscope. Separation between these two you have to find out V naught plus UE over here. So V naught is already known. So UE, how do you find out UE? 1 by VE minus 1 by UE is equal to 1 by FE. So from that you can find out. So hope you understand children. So you can do by yourself. Now a small telescope has an objective lens of focal length 144 centimeter and eyepiece of focal length 6 centimeter. What is the magnifying power of the telescope? Very easy, and tube length. So therefore magnification power is equal to minus F4 by Fe. Minus sign denotes that it is an inverted image. So that is equal to minus 144 divided by 6. So you take so 24 is the magnification power, I guess. So magnification power is 24. Minus sign denotes that it is an inverted image. Tube length you can find out, that is equal to F4 plus mod of Fe. So that is equal to 144 plus 6 is 150 centimeter. So hope you got it children. The last question, a giant refracting type telescope at an observatory has an objective lens of focal length 15 meter. So this is objective lens of focal length 15 meter. An eyepiece of focal length 1 centimeter is used. So this is eye lens of focal length 1 centimeter is used. What is the angular magnification? Of course you know that angular magnification is equal to what? Minus F4 by Fe. That is equal to minus 15 divided by 1 centimeter. Centimeter convert into meter. That is equal to 10 power minus 2 meter. So I am writing 10 power minus 2, that is equal to 1500 is a magnification. Now first part is over, that is very easy, but only thing you have to be careful, you have to convert into same unit. Now if this telescope is used to view moon, I am going to view moon. So here it is a moon. Moon is over here. I am going to view the moon. Where is moon? Moon is at infinite distance. So therefore the ray of light from infinity is falling on the lens and then you get an image at F. This is A dash B dash. This is H. This is H dash. But theta is going to be the same. The object is at infinity. So image is at F. Where is the object? Here it is given the diameter of the moon is 3.48 in 10 power 6 meters. So it is 10 power 6. So that is H is equal to 3.48 into 10 power 6. The radius of the lunar orbit, that's nothing but the infinite distance. So this distance is nothing but, this distance d is equal to 3.8 into 10 power 8 meter. So you are asked to find out H dash. Very simple geometry children. So now you see, you will be thinking that, oh, so such a simple question, it takes only 2 minutes for you to complete it. So how? See here. So now this is one triangle. Okay, so let me take here. This is one triangle. This is also one triangle. Is this vertically opposite angles are equal? Yes. So therefore can I write it as tan theta is equal to H by, is it tan theta is equal to H by D? Yes. Here tan theta is equal to what? H dash by F. So equate both, that's all. So equate both. H by D is equal to H dash by F. I want to find out H dash. Therefore H dash is equal to H into F divided by D. That is all. What is H? 3.48 into 10 power 6 divided by into focal length. What is the focal length? 15 meters divided by D is 3.8 into 10 power 8 meters. Approximately you cancel it. 3.48, 3.8. Approximately how much you get? So for example, you get 0.9 or 0.85. So 15 into 0.9. So that is approximately equal to 14 into 10 power minus 2, or you can say 14 centimeter approximately. So 15 into, suppose if I want absolutely, let me just find out, 15 into 10 power 15 into 3.48. So that will be 52.2 divided by 3.8. That will be 13.7 I am getting. So that is equal to 13 point, absolutely equal to 13.7 centimeter. So therefore I am taking 14 centimeter, or if you want you can write it as 13.67 centimeter itself is the answer. So hope you understand the optical instrument, hope you understand the numerical based on optical instruments, and you have to learn how to draw this ray diagram of compound microscope, telescope, and what are the advantages of telescope, reflecting type telescope. So thank you children. If you have any doubt you can always reach me out and get it clarified and get very good marks. Thank you children.